Welcome to Benchmark. Today we're going to talk about cables. We're going to talk about snake oil. And, is there such a thing as snake oil cables? Or are these claims that we hear about cables changing the sound of our audio system? Are these true? Should we buy into that? Should we buy the $500 cables, the $5,000 cables, the $20,000 cables? Are these going to make a difference in the way our system sounds? Well, I would contend that if the cable makes a change in the way your system sounds, it's a sign that you've got a cable that's not transparent. You've got a cable that's in some way changing the audio. And so cables have a very specific purpose, and that is to get the signal as clean as possible from point A to point B. And you should not be thinking of your cables as a way to tune your system. Now, let me give you an analogy. So let's suppose that you're a designer of race cars. Okay, and you've got an engine control unit, and that's communicating with the various sensors on the engine. And what kind of cables are you going to use to connect those? You're looking for a highly reliable cable. You're looking for a cable that can withstand the environment that it's going to be exposed to in the race car. So it's got to be resistant to high temperature. It's got to be durable. It's got to be resistant to abrasion. It's got to be properly dressed in the chassis. But what I'm not going to do is I'm not going to select different cables to try to tune my engine performance. I'm going to select a cable that gets the signal from point A to point B, and then I'm going to adjust my engine control unit to tune my engine. So what I see a lot of times in audiophile circles is this mentality that we're going to tune our audio system using exotic cables. And what I'd like you to think about is that really the purpose of the cables is not a tuning device, but the purpose of the cables is to be as transparent as possible. So if you're trying to change the way your system sounds, one of the first things you should do is think about speaker placement, listening position placement. Think about your room. Think about the speakers themselves. And then work your way down the chain and think about various parts of the chain, the electronic chain, the amplifier, the preamplifier, your D to A converter, and even your streaming device and what files you're streaming, or what CDs or other material, vinyl, whatever you're playing, all the way to your source device. The very smallest incremental changes are actually going to come from the cables themselves. Now, does this mean that cables don't matter at all? No, they very much do matter. If I use the wrong type of cable on a digital signal, for example, if I use an RCA cable that's not a coaxial cable, it's not a 75 ohm cable, and I use that cable to hook up my SPDIF digital coaxial signal from maybe a CD player to an outboard D to A converter. If I use the wrong kind of cable, I may find that at certain sample rates, that cable just plain doesn't work. And it's because of the cable reflections down that cable and back, because the impedance doesn't match. And so this is very important in a digital cable, that in a digital audio system, coaxial cables need to be 75 ohm coaxial cables. You don't want to use 50 ohm coax in an audio system, because the inputs and outputs are terminated at 75 ohms. I've got coaxial cables out on the bench that are designed for RF testing. and those cables are all 50 ohm cables. My RF test equipment is designed with 50 ohm output impedance and 50 ohm terminating impedances, and if I put a 75 ohm cable into my RF gear out on the bench, I'm going to have all sorts of problems. I'm going to have erroneous measurements, I'm going to have signal loss, I'm going to have reflections, and so it's important in a digital environment to use the proper cable impedance. Now, one of the things that was done in the early days of digital audio is somebody had the brilliant idea that it would be wonderful to be able to use XLR cables for digital audio. So they said, well, gee, let's put digital audio on an XLR connector, and we can use all of our existing XLR cables, and we can send digital audio around the studio with our existing cables. Well, it turned out to be a really bad idea because none of those cables were the correct impedance. And so we very quickly learned as an industry that those cables needed to be matched impedance. They needed to be 110 ohm twisted pair using standard XLR connectors, but very different wire inside. And so if you go to our website, you'll see that we sell XLR cables for analog audio, and we sell a completely different kind of XLR cable for digital audio. And just to keep those easy to identify, we sell all of our digital cables with a blue jacket on them. We can get them in any color we wanted to, but we ordered the cable with a blue jacket so that the digital cables are easy to identify and easy to separate from the analog cables that we're going to use for line level signals and for microphone signals. So there's an instance where the type of cable you use is very, very important. Now let me tell you a little story about a trade show that we did. We were sharing a room with several other vendors. There was a speaker vendor there, we had our electronics there, and there was another vendor that was a cable vendor. So, you know, okay, we'll split the cost of the trade show room 3 ways, and you know, the cable guy will bring his cables in, we'll bring our electronics in. We really liked the speakers, and so we were very happy about that. So cable guy comes in, and he's got a pair of speaker cables that are obviously made out of welding cable. So maybe 1,000 strands of copper, very flexible, capable of high currents, very low resistance, and you know, on the surface it seemed like, yeah, this is a great way to make a speaker cable. Well, it turns out that they were really very poor speaker cables. They were good at low frequencies because of the very thick copper. But he had these cables laid out individually on the floor. So there was one black cable and one red cable. And I brought those into the lab after the show. He says, you know, hey, we'd love to have you test these. And so, okay, I'll go ahead and test them. But you know, we had a discussion at the show as to, you know, this really isn't the way you should be building speaker cables. You shouldn't have this large separation between the two conductors, because that creates a large inductance, and the inductance rolls off high frequencies. So bringing these into the lab, I could separate the wires and watch the high frequencies roll off half a dB or so, and bring them back together and watch the high frequencies improve. And then even worse, if I coiled up one of the conductors and then coiled up the other conductor, that would roll off the high frequencies even more. And then depending on how I overlapped those coils and which way the coils were wound, I could change the frequency response of these cables just by the way I put them on the floor. Now, not only were these ordinary welding cable with fancy snakeskin jackets on them, but they were also $20,000. And for $20,000, you got a cable that didn't really work very well. Where you put the cables had a big impact on how they actually sounded, and how you laid them on the floor made a difference in how they performed. So you could spend $20,000, or you could actually buy a $5 piece of zip cord and actually have something that was a better cable than this $20,000 solution. Now, I'm not saying go out and buy a piece of zip cord, because obviously we can do better than a simple piece of zip cord, but the point is that that piece of zip cord would give you a more consistent response than what we got out of those $20,000 cables. So, we said we don't want to be a part of this in future trade shows. We will not be showing with your cables. If you're going to charge $20,000 for a cable that doesn't work, we don't want to be a part of it. Obviously, we get heat from time to time from cable manufacturers when we talk about, we use the word snake oil for some of these cables. Let me give you another example. In the early days of the benchmark DAC1, we had one come in for service, and it's got this really fancy USB cable stuck in the connector, and it's carefully wrapped up in the box, but the USB cable absolutely will not unplug from the DAC. And this is the A-style connector, the doghouse shaped connector. And there's no way you could get that connector out. It was in there, you put it in, and it's never coming out. We talked to the customer, and he says, oh, I spent $1,000 on that cable. Anything you can do to get that cable out and salvage the cable, I'd really appreciate it. At that time, the DAC1 was $950. And the USB cable was $1,000. So got a $1,000 cable stuck in the back of this. And so we took it into the shop, and one of the technicians very carefully unsoldered the connector, and we put a new connector on the board and serviced it under warranty, and put the unit back in the box along with the customer's cable, and sent it back to him and said, well, send the cable back to the manufacturer. Obviously, there's a tolerance issue here. This cable's not made to USB specifications. It goes into certain USB connectors and locks itself right in there. There was nothing wrong from a performance standpoint with the cable that we ship with every DAC1 and every DAC2 and every DAC3. They're generic USB cables, but we know from testing and know from running jitter tests and running all sorts of different measurements that those cables work flawlessly, even though they're a $5 USB cable. You may have some USB inputs that are sensitive to jitter, not on a benchmark product, but you may find products that do. And so certain cables and different cable lengths, USB cables, possibly could make a difference. I've never actually seen any solid measurements that show that, but theoretically that might be possible. But suffice it to say that the $5 cable that we ship with our products, the USB cable. There's nothing special about it. It just meets USB standards as far as data transmission bandwidth and so forth, and it's just a stock USB cable, and that's all you need on a benchmark DAC. You don't need to spend $1,000 on a cable that's going to get stuck in the jack on the back of the unit. Now, we had another DAC 1 come in that had a similar problem. Now, this one had an aftermarket headphone cable stuck firmly in the headphone jack on the front of the unit. And again, there was no way you could pull this thing out. This is a 1/4-inch headphone jack. How in the world can a 1/4-inch headphone jack get stuck into the headphone jack? And beautiful cable, you know, gold-plated plug on the end, really beefy 1/4-inch plug. Beautiful piece of cable to look at. And of course, it had been unplugged from the headphones so they could send it into us. And no way to get it out. So again, technician unsolders the connector, removes it from the board, put a new connector in, service this under warranty, and send the customer's cable with the connector still attached back to him along with his repaired DAC 1. What the issue there was is they had taken a standard off-the-shelf 1/4-inch phone plug and plated it with very, very thick gold plating. You know, there had to be some value at least in all of that gold that was on the connector, and it looked absolutely gorgeous. But when you put a micrometer on it, you could see that it was well over 1/4-inch and too large to actually go into most headphone jacks. There's a lot of snake oil out there. There's a lot of expensive cables that don't work. Now let's talk a little bit about the connectors that are on your speaker cables. One of the things that you want to avoid are the spring-loaded banana plugs. We've done a number of measurements in the lab. Whenever we've tried to measure an AHB2 with spring-loaded banana plugs, the distortion is just about double or triple what we'd expect it to be. And it turns out that there's more distortion generated across that spring-loaded banana plug than there is from the entire AHB2 power amplifier. Simple solution is to use a locking banana plug. So these plug in, and you turn the knurled screw, and they tighten up internally with 4 individual fingers. That makes a very reliable, very low impedance connection. The other thing that we found is that spade lugs can be very unreliable. If they're clean, if they're perfectly flat, and you tighten them down sufficiently in the binding post, they work wonderfully. Problem is, the minute you bump the cable, they tend to loosen up. And so after bumping them multiple times, it's very common to find them loosened up to the point where they're producing more distortion than the entire AHB2 power amplifier. So connectors are extremely important. Connectors are, to a large extent, what determine the reliability of your cable. So we always use Neutrik XLR connectors. We use Neutrik Speak-On connectors, and it's because these are proven connectors that are used widely in sound reinforcement applications where systems are being put up for one night, torn down, moved to another city, put up, taken down, and so day after day these systems are deployed and taken down, and these cables are unplugged and plugged in, and they're stepped on and all sorts of abuse. They're designed to take that abuse and give you good, reliable connections. In our own facility here, we use the Neutrik connectors and Canary cables in all of our test stations. And so maybe 20, 30, 40 times a day, we're plugging in and unplugging, testing the next piece of gear, plugging that in, unplugging, testing the next piece of gear, plugging in, unplugging. And about once every 5 years, we have to replace those cables. They're that durable. They can go through that many cycles. But eventually the plating on the XLR pins and the XLR sockets wear out, and that's usually what determines end of life for those. Now, the Canary cable that we're using on those is surprisingly durable. That's a 4-conductor star quad cable with a braided shield and a number of reinforcement strands in there. Turns out it's a super durable cable. We don't find that those fail at our test stations. What does eventually fail are the connectors themselves. Now, on the back of the AHP2 power amplifier, you'll find that we have speak-on connectors, and we have binding posts as well, so you can use the binding posts, but we actually recommend for best performance that you actually use the speak-on connectors. And the reason for that is that those are high current connectors. They're very durable. They have a wiping action when you put them in and lock them in place. They stay locked in place. And these are industrial connectors that are used in sound reinforcement systems, used for very high power speakers, for line arrays and so forth. So if you go to a concert, every single speaker you see in that line array is connected with speak-on connectors. So very proven reliability and very low impedance connections. No measurable distortion across those connections. So that's what we recommend using. And if it had been my choice, there would have been no binding posts on the back of the AHP2. I had sales department twisting my arm, saying, "No, we've got to put binding posts on there. Everybody's got binding posts." So you can thank the sales department for the binding posts on the back of the AHP2, but my personal preference would have been to leave those off there entirely. But the whole point of benchmark cables is to give you a reliable connection that gets the signal from point A to point B with maximum integrity, so without loss of quality. And it doesn't take a $5,000 cable, a $10,000 cable, or a $20,000 cable to do that. It takes well-designed cable, which is readily available. We use the Canary star quad cable, for example. Also, we use coaxial cable for the coaxial connections, the SPDIF coaxial connections. There's all sorts of wonderful 75 ohm cable that's readily available. That's all of the specs are available to us to look at, and so we're selecting the best materials and giving you a cable that's reasonably priced, that reflects the actual value of the cable and the connectors and the labor that it takes to put them together. So I hope that helps avoid some of the pseudoscientific claims about cables. Take a practical approach to it. Don't look at a cable as a way to tune your system. Look at a cable as a way to reliably get a signal from point A to point B. Again, remember, I wouldn't use a cable to tune a race car. I use the cable to get the signal from the sensor to the engine control unit, and then tune the engine control unit to tune my engine. So I hope that helps, and I hope that in the long run can save you some money and some frustration when you're trying to put together a great audio system.